Let's do some reminders of proportional versus non-proportional graphs. This is really important, and it's actually pretty easy. Remember that if a graph is proportional, the y-intercept is 0. If it's non-proportional, the y-intercept is any number except 0. So it has to be something else besides 0. If there's another number besides 0 for your y-intercept, then it's non-proportional. If it's proportional and the y-intercept is 0, that means that our graph, this would be referring to our graph passes through the origin. Remember, the origin is at 0, 0, so it passes through the center of our coordinate plane. If it is non-proportional, it does not pass through the origin. If we are looking at a table, we will see that a proportion has a unique ratio of y over x. We can take every pair of points in our table and divide y divided by x, and it will be the same. But if it's non-proportional, it does not have that unique ratio. If the graph is proportional, it will be in the form y equals mx. Just like that. An example, y equals 3x. Notice there's nothing added or subtracted on if it's proportional. If it's non-proportional, it has the whole form where we actually have a y-intercept besides 0. So an example might be y equals 3x plus 2. Or y equals 2x minus 3. Those are both examples of non-proportional. And you see how they have a y-intercept other than 0. Proportional has a y-intercept, but the y-intercept is 0. Okay? Here's a picture of a graph. Proportional, you see right here, it's going through the origin. That is the origin. That's all, and it's linear. We have to know that it's linear. So that is the only thing that we have to really think about. It does have to be linear. It does have to be a straight line, and it has to go through the origin. Okay, non-proportional. Notice my y-intercept is 3. That's what makes it non-proportional. It is not going through the origin, and so therefore it's non-proportional. So let me give you an example of a table. I'm going to have to think for a minute here. Okay, so here is an example of a table. And we said that on a table, proportional has that unique ratio of y divided by x. So if I take this first point, and I do y divided by x, 4 over 2, we get 2, right? If I take the next point, and I do y over x, 6 divided by 3, that is also 2. And if I checked this, 8 divided by 4 is 2, 10 divided by 5 is 2, and so that's what makes it proportional. Okay, let me show you an example of one that would not be proportional. And I'm thinking for a second, so okay, so here is an example. If I look at each of these pairs, I mean, it should be pretty obvious, right? If I, and even this one, if I do 7 divided by 1, 11 divided by 2, those do not all come out to be the same thing. They all come out to be different numbers. And so therefore, that's another way to check to see. We can also see right here the y-intercept is 3. So that makes it also non-proportional. Okay? If we have a verbal example, we want to make sure that there's no extras. There's no extra fees, no nothing. It just has a rate. And it says Sam gets paid $7 per hour to deliver the pizzas. If we wrote that equation, it would be y equals 7x. All we have is that rate. Sam does not get paid anything extra. But in the second example, for non-proportional, it says Sam gets paid $7 per hour and an extra $100 if he uses his own car. So his equation for non-proportional would look something like this. So non-proportional has extra fees added onto it.